Howdy, folks. So it came to my attention that not everyone is totally familiar with correlations and t-tests. I kind of thought that statistics was a pre-existing class, but if you're a little rusty or if you haven't taken statistics before, or if correlations haven't been covered in your classes so far, I just wanted to make t-tests and correlations totally clear. So just to go over it again, a t-test is an analysis that compares two numbers. So if you're comparing the height in boys and girls, then you would use a t-test. Or if you're comparing the effect of a drug on a person before and after they take a drug, you would use a t-test because you're looking at two numbers, two averages, and you're checking to see whether there's a difference there. Now, for correlations, you are again going to be working with two variables, but in this case the variables are a little different. If in the t-test you have your independent and your dependent variable, in a correlation you don't necessarily have an independent and a dependent variable. Instead, in a correlation you just have two variables and you're just checking whether or not the variables move together. So a lot of people use the word correlation in everyday speech to mean that two things are connected, and in statistics it does have a similar meaning. For example, this graph here shows a correlation between shark attacks and the amount of ice cream sold in a given month in the summer. And so it looks like as ice cream sales go up, so do shark attacks go up. However, this graph is often used to show that a correlation is not necessarily a causation, causation being one of the topics we covered in the previous videos. Uh, the idea here being that ice cream doesn't cause shark attacks. What's going on is that, well, the hotter it is, the more people eat ice cream. And also, the hotter it is, the more people go into the ocean and get attacked by sharks. So it's important to be aware that in a correlation, you don't necessarily have a direct connection there. And sorry, I misspoke. In the next week of videos, we will talk more about correlations and causation. So stay tuned for the next module. But that's kind of a quick and dirty thing there. What a correlation is in statistics is really just when you plot two sets of numbers together and you see how they move, whether or not they're related to each other. So a good way to think about this is in terms of the different types of correlations you can get. So no correlation, you can imagine x variable and a y variable. So say for example, this x variable is how smart you are, and this y variable is your shoe size. And so probably there's no relationship between your intelligence and your shoe size. So the bigger your intelligence number, it doesn't matter how big your intelligence number is, your shoe size is just going to be moving around in a random fashion. And so we know that because there's a random association between these two variables, that in other words, there's no association between the two, there's no correlation, and so this horizontal line represents no correlation. There's a totally random relationship there. Now, a significant correlation is going to be represented by either a positive or negative correlation. A positive correlation indicating that as one variable increased, the other variable increased. A negative correlation indicating that as one variable increased, the other one decreased. So an example of a positive correlation might be, for example, well, it could be like that ice cream and shark attacks. It could be, say, for example, as your height goes up, your shoe size also goes up. People who are physically taller tend to have larger feet because overall they're just a bigger person. Uh, let's think, can you think of a negative correlation? What two variables would be in opposite directions from each other? How about this? For people who exercise more, so let's say they get, you could say this variable is the number of hours of exercise per week, and the amount of money they have to spend on doctor or medical visits per year. And so the more you exercise, the less money you have to spend on medical visits. That's a very obvious, clear negative correlation because the more you exercise, the healthier you will be, which means that you'll spend less money at the doctor. Now, it's not a perfect correlation. It's not a one-to-one ratio. It's not like if you exercise 5 hours, you will always spend $500 less on the on the doctor, but it's going to be a negative correlation. So generally, the more you exercise, the less money you would spend. So at this point, I would really like to encourage you to give it a shot and see if you can come up with variables of your own that fit each one of these three types of correlations. On the next slide here, we're going to have a couple more examples just to make sure things make sense. So if you'd like, pause the video here and see if you can come up with examples on your own. Okay, so here are a couple more examples. Turns out I guessed this correctly. Um, the more you weigh, the more tall you are. I didn't mean to guess it. They're pretty similar to the examples I gave. So the more you weigh, the more height you tend to have. Makes sense that people who are taller would tend to weigh more. People who are tired tend to have gotten less sleep. So there's a negative correlation there. But there's really no relationship between shoe size and hours of sleep. So that's a no correlation graph. And as I said in the previous videos, the way you report a correlation is going to be pretty much exactly the same as a t-test. You're going to say that you did a correlation, you're going to report the statistics, and you're going to explain what that meant in words. So what you might say, if let's say you had a positive correlation between height and shoe size, you could say a correlation analysis found a significant relationship between height and shoe size, parenthesis r equals 0.9, p equals 0.02, figure 1. As shoe size increased, so did height. And so the interpretation for your correlation is just going to be to say what the correlation was. As one thing increased, the other one did what? Okay, hope that helps, and have a wonderful day.